Hey there, Mr. Sutton here, bringing you the Algebra 2 8.2 lesson on two-way tables and probability. In this one, we will be learning how to construct two-way frequency tables, and based off of that, we will also find and interpret relative and conditional relative frequencies, and then we'll also use conditional relative frequencies to find some probabilities. So let's see what all these big words are all about. We're going to start things off with some definitions. This is one of those lessons where most of what we're asking you to do is pretty straightforward, just a lot of calculator number crunching, but it all depends on knowing what we're asking for, knowing the definitions of the crazy words we throw at you. So here's the first one, two-way table, or two-way frequency table, it's sometimes called. When we ask you to build one of these, we're just asking you to make a table with data that belongs in two different categories. The way that we're going to structure it is we're going to have the rows to organize the data from one category, and the columns will take care of the other category. So here's a look at what one of these might look like. So we have a table here, and we've got rows for one category, like one question. Maybe this is, we asked students, do you like cookie dough, yes or no? The yeses are in the first row, the nos are in the second row. And then we have a second category organized by column. Maybe these are students who, turn in their homework on time and don't turn in their homework on time. Now those two categories, they might have some relation to each other, or they might be completely unrelated. It doesn't really matter. We can put all this in a table. And there's going to be some overlap between these two different groups. There are going to be some students who like cookie dough and turning in their homework on time, and some who, prefer neither, and some who prefer one of those things. In any case, we can have one of these tables to organize all that. Now, once you have things in this table, one thing you can do with this data is add it up, see what the totals are. We can come up with totals for each of these columns. So down here maybe are the totals of students who do their homework on time versus don't. And we can also do that for the rows. Here's all the people who like cookie dough, here's all the people who don't, and here in the lower right are the combined people. These are all the people who answered the cookie dough question, and here's all the people who answered the homework question. It should actually total up the same thing whether you're doing this by a column or by a row. This is the grand total of everything, which you could also get by just adding these original four entries together. So we also want a way of talking about these original entries versus these totals entries. They're called different things. The fancy name for these non-total table entries is joint frequencies. These are the non-totals that you start with. So let me just draw an arrow there to point those out to you. Now this is in contrast to these other frequencies that are on the margins of your table. These are actually called the marginal frequencies. These are the row or column totals off to the right and on the bottom. And this 15 down here, this lower right one, I call that the grand total. I don't think there's a special name for it. It's just another marginal frequency. So this is one type of table that you might be asked to build. Once you've built one of these, we might ask you to go ahead and build another type of table in which we have what are called the relative frequencies. These are the ratios of each of these frequencies to the grand total. So basically we'd be asking, what percentage of this grand total in the lower right do each of these different little categories make up? What percentage of students like cookie dough and doing their homework on time would be what we're asking here. So those are relative frequencies. And a related one that we can also ask for is something called the conditional relative frequencies. Once you have one of these relative frequency tables, which we're going to do later on in this lesson, we can take a look at the ratio of the joint relative frequencies to the marginal relative frequencies. Basically asking, of the students who liked, cookie dough, what percentage of them also like doing their homework? That sort of question. So we're going to go on and build a few more of these tables now. All the problems we're doing in this lesson, we're going to use the same data just to make things a little easier to follow and more efficient. So let's say that any survey that's asking juniors and seniors whether they're attending a school concert, we have 106 juniors and 114 seniors responding, and of those, 42 of the juniors and 77 seniors said they planned on attending. They want us to organize these results in a two-way table. and then they want us to find and interpret the marginal frequencies. So we're going to start off by building kind of the skeleton of this table, just so we're all on the same page. So we have really two categories of information. We have the age of the students, juniors versus seniors. So we'll make that maybe the rows. And the other category of information is whether they're going or not going. So we could make that the columns, or vice versa. It doesn't actually matter. In fact, let's do it the other way around. Let's build it, and it doesn't really matter which way we do this, but we have to pick a direction. Let's build it so that the attending versus not attending are the rows, and the juniors versus seniors are going to be our columns. And again, you could have done it the other way around. It won't really make a difference for the final results. So we also have a row and a column for the totals, just like we saw on that last intro slide. So we're going to be filling this in, or you're actually going to be filling this in a moment. Just as a little tip for when you do this, because you might have noticed that there are some boxes that this information that they gave us doesn't quite cover. My advice would be fill in what you know based on what they gave you in the problem, and then use addition and subtraction to fill in the gaps. So if you, let's say that you know this value and you know the total, you could use subtraction to figure out this missing value in between. Or you could add these up to find the total. So pause the video and give it a shot. And then once you're done, they also want you to find and interpret these totals columns, these marginal frequencies. Like, what do these numbers actually mean in real life? Give it a shot. All right, so starting just kind of from the beginning of the sentence and putting things in as we find them, they said there's 106 juniors. So that would be the total juniors, which would be down here in this entry. And then there's 114 seniors, so that can go down here. And then we had 42 juniors attending, so juniors attending is this box right here. And then 77 seniors attending would be this cell right next to it. So now that we have all this, I'm just going to go ahead and fill in the gaps based on what we have. So, and I'm just going to start at the top and work my way down. It doesn't really matter what order you fill these in. So let's start with the total attending. 42 seniors, or 42 juniors rather, plus 77 seniors would be a total of 119 students overall. And you can use a calculator for any piece of this if you want. Then this next one here, if we have 42 juniors attending and 106 juniors total, 106 minus 42 is going to give us 64 juniors who are not attending. And then over here, 114 minus 77. Let me just go to Desmos for this. I mean, I'm going to be resorting to the calculator soon enough anyway. Might as well bust it out here. So 114 minus 77, that gives us 37. So that's how many seniors are not attending. And now we can come up with the total that are not attending. 64 plus 37 is going to be, let me see, that's like 90 plus 11, so 101. And then the total overall students, you could do it by the this column or add up these rows. Either way, you're going to get 220. All right, so now they want us to interpret what all of this means. This 119, that's the total students attending. 101 is the number of students not attending. 106 down here is the number of juniors who answered the survey. And then 114 is the number of seniors who answered the survey. And then this 220 is the total students overall who answered the survey. For our next example, we're going to use our survey results from example 1. And here's the table that we just made here to make a two-way table that shows joint and marginal relative frequencies. And then they just want us to interpret one of the joint and one of the marginal frequencies. So basically, we're just going to take all of these numbers you came up with in example 1 and divide each of these entries by the grand total. And that's just going to give you a decimal, just round it off to 3 decimal places. So pause the video and see if you can build that table. All right, let's see what we came up with here. So here is kind of my skeleton table to put all this stuff in here. And I'm going to be going straight to Desmos for most of this. But just to show you what I'm doing, in this juniors attending cell, I'm going to take the 42 that I had initially and divide that by the total of 220. And whatever that comes out to is what I'm going to actually write in there. So let's see, 42 over 220 comes out to about 0.191. So that is my joint relative frequency there. Let me do this next one now. We have seniors, so that's going to be 77 over 220 for that one. There we go, 77 over 220. And plugging that in, I've already got this over 220, so I'll just go up here and change the 42 to a 77, and that's exactly 0.35. So I didn't really need the squiggly equals there. All right, let's do not attending now. So that's 64 divided by 220, and that is 0.291. And then finally, we've got 37 divided by 220, which comes out to 0.168. Now we could do the same sort of thing for all these totals columns. You could do 119 over 220, or you could simply add these together. Let me just do 0.191 plus 0.35 adds up to 0.541. But again, if you had done 119 divided by 220, you should get the same result. There's just two different ways of getting it. And then let me do the next one here. We've got 0.291 plus 0.168. That's 0.459. And then adding up my rows. So we've got 0.191 plus 0.291 is 0.482. And then adding these up, let's see, we've got 0.35 and 0.168 adds up to 0.518. And then finally, if you've done this correctly, this last thing, let me just show you here, 0.482 plus 0.518, that should add up to exactly 1. Because if you think about it, this is just 220 divided by 220, so you should get 1. Now, having said that, depending on how you round things off, you might get like 1.001 or 0.999, and that's fine as long as it's 1 or very close to 1. So how about this interpretation piece? Let's take a look at this 0.191. What does this actually mean here? Well, this means that 19.1% of students who answered this survey are juniors who are also happening to attend this concert. And you could say kind of the same thing about all these other joint things. This is 35% are seniors who are attending, 16.8% are seniors who are not attending, and so on and so forth. Now, in terms of the marginal relative frequencies, I'm just going to take this 0.541. This means that 54.1% of students who answered the survey are attending. Now, if you wanted to break it down further and talk about what percentage of juniors are attending, these won't tell you that directly. You have to do a little bit more number crunching in order to figure that out, and that'll be the topic of our next example. For the last type of task we're going to do here, again, we're going to use those example 1 survey results, and this table I've kind of cut it and pasted here. This is the relative joint and marginal frequency table that we built back in example 2. So what they want us to do with this kind of at our disposal here is make a two-way table showing the conditional relative frequencies. And they want us to do this based first on the row totals, and then they want us to do it again based on the column totals, and then interpret one of the conditional relative frequencies in each table. Okay, so basically what they're asking us to do with this conditional business is just to divide each of our joint relative frequencies by its row or column's marginal relative frequency. So, for example, 0.191 divided by this total marginal frequency. So we're going to do that first for the rows, and then we'll do it for the columns. Pause the video and see if you can build a table based on doing this for the rows first, and then maybe interpret one of those results you get in terms of what it actually means. All right, so we'll start with the top left here. So I'm going to take 0.191 and I'm going to divide it by 0.541 because again I'm doing this for the rows first. This is what they asked us to do in part A. So 0.191 divided by 0.541. So I'm basically dividing one percentage by another is what's going on here. And of course I'm going to use Desmos for this. So let me do a fraction, and let me just clear all this out. All right, so fraction 0.191 divided by 0.541, and that's roughly 0.343 or 353. So that's our conditional frequency based off of rows for that upper left one. And then let me do the same thing for the senior attending, so 0.35 over 0.541. And I'll just change this 0.191 to a 0.350, and that comes out to 0.647 if I round it off. Now one thing you will notice is that these two things should add up to 1. And I mean, that makes sense because if you did 0.541 divided by 0.541, you would get 1 in that cell entry right there. Now we're going to go down to the not attendings, and we're going to do 0.291 divided by the not attending. That would be the marginal relative frequency. So divided by 0.459. So going back here and doing 291 over 459, that's going to be 0.634. And then this last one, 0.168 over 0.459. Just make that one little change in my fraction, 168. And that comes out to 0.366, which again, if you add these two numbers together, you will see that these also add up to 1. So let's go ahead now, and we're just going to interpret this upper left one here, although we could do it for anyone. What does this 0.353 actually mean? Well, since we did this with respect to the rows, this means that of the students who are attending, 35.3% of them are juniors. Of the students who are attending, because we did it by rows, 35.3% are juniors. Over here, 64.7% of the attending students are seniors. Down here, 63.4% of the non-attending students are juniors. So we're basically breaking each of these attending, non-attending categories down by juniors versus seniors. Now this number up here is not saying that 35.3% of juniors are attending. Because juniors, that wasn't the category we used to divide everything. So that's what's making all the difference here, is which category you used to do your division. So we're going to do one more of those conditional tables, this time based on column totals instead of the row totals. So we're using these column totals down here. Pause the video and try that out. All right, so doing our table again, all the blanks in there. Now up here in the upper left, we're going to do 0.191 divided by 0.482 and see what that comes out to. So we've got, let's see here, 191 over 482, and that's 0.396. And then moving over here, we've got 0.350 over 0.518. 0.350 over 0.518, that comes out to 0.676. And down here now we've got 0.291 over 0.482. So 291, 482, that's 0.604. And then last but not least, we have 168 over 518, giving us 0.324. Now let's go ahead and interpret this upper left just for comparison with what we did before. Since we did the division using these column totals here, what we're saying here is of the juniors surveyed, 39.6% of them are attending, and if you want to go a little further, 60.4% of them are not attending. Of the seniors surveyed, 67.6% of them are attending versus 32.4% not. So these are the types of questions you can answer with one of these tables. Now, you didn't have to do all this work if you just wanted one of these values. If you just wanted to know what percentage of juniors were attending, you just needed to figure out how many juniors were attending, which was 42, and divide it by the total number of juniors, which you've maybe had to do. I think they also gave you that in the problem. However, this is really nice because we can compare several pieces of information at once. Looking at this table, for example, we see that if you randomly ask a senior, they're much more likely to say they're attending than if you randomly ask a junior, which you might not get just by answering this one question. So I hope you will find this lesson relatively helpful in your doing of the homework. Until next time, Mr. Sutton signing off.